Hello, I am Tajul Poddar. Uh, Now I am presenting a paper named Effective Machine Learning Approaches for Credit Card Fraud Detection. The paper has been accepted in WICT conference 2020. My paper ID is 3. This this is the overview outline of the presentation. First of all, I have to discuss the introductory information that what is credit card and what is the importance of fraud detection of for credit card, and then I will discuss about the related works and main contributions. Third topic is methodology, feature selection. There's also discussion, comparative analysis, and conclusion and references. Okay, credit card generally refers to a card that is assigned to the customer. That means cardholder, usually allowing them to purchase goods and services without within credit limit or withdraw cash in advance. Credit card provides the card holder an advantage of the time. That means it provides time for their customers to repay later in a prescribed time by carrying it to the next billing cycle. Credit card frauds are easy targets without any risks. A significant amount can be withdrawn without the owner's knowledge in a short period. Fraudsters always try to make every fraudulent transaction legitimate, which makes fraud detection very challenging and difficult task to detect. In Okay, then normally with different frauds, mostly credit card frauds, often in the news for the past few years. Frauds are in the top of mind for most of the world's recent days and world's population. Credit card data set is highly imbalanced because there will be more legitimate transaction when compared with a fraudulent one. Okay. In this paper mainly discusses the performance of random forest, AdaBoost, CatBoost classifiers for classification of credit card fraudulent activities on a data set regarding to the credit card data set, regarding to the credit card data. In this paper, the most important features are also selected by applying these classifiers. Pearson correlation plot and density plot of features are also implemented in this paper. Results show that among the classifiers considered, RF and catalog boost have the best performance, obtaining 99.92% accuracy in terms of detecting credit card frauds. Now I am discussing about the related works. Multiple supervised and semi-supervised machine learning techniques are used for fraud detection, but we aim to overcome three main challenges with credit card frauds related data set. Strong class imbalance, the inclusion of labeled and unlabeled samples, and to increase the ability to process a large number of transactions. Actually, various approaches have been conducted in order to detect the fraud, such as Kenya's neighbor, that means scan classifier, Bayesian algorithms, support vector machines, and neural networks, etc. Different supervised machine learning algorithms like decision trees, list score regression, logistic regression, and SBM are also used to detect fraudulent transactions in real-time datasets. Two main methods can be under random forests are used to train the behavioral features of normal and abnormal transactions. They are random tree-based, random forest, card-based. Okay, and this Masibi Zariapur used naive bias, Canon SBM classifier, and bagging ensemble learning algorithms for credit card fraud prediction. Bushtuminath used logistic regression, SBM, random first and decision tree in credit card fraud data set to analyze the behavioral patterns. Though Card transactions are always unfamiliar when compared to previous transaction made the customer. This unfamiliarity is a very difficult problem in real world when are called concept drift problems. Concept drift can be said as a variable which changes over time and in unforeseen ways. These variables cause a high imbalance in data. The main objective, one of the main objective of our research is to overcome the problem of concept drift in order to implement on real world scenario. Now now I'm giving some description of the data set. There are 492 fraudulent transactions and the total transactions are to 2,84,807, and it is a highly imbalanced data set. About 0.172% of all transactions belong to the positive class, that means fraud class. Numerical input variables are presented here due to the principal component analysis transformation. Because of the confidential reasons, the unique features and more background data about the dataset have not been offered. Features beyond V2, V3, 4, V3, V28, etc. are the principal components achieved with principal component analysis. Okay. Firstly, if we can describe that, firstly, to divide the class holders into different class or groups on the transaction amount such as high, medium or low using range partitioning, we can use clustering method or sometimes this type of method. Actually, in order to balancing the data set, we have to pre-processing the data set. We have to apply pre-processing stage. This is the methodology. In 10 test splitting, test size is 10% and training size is 90%. Okay, and feature selection, we use random forest, adaptive boosting, cat boosting as a classifier, not only in the classifier stage but also using these classifiers we will see the important features. Okay, then this figure shows that the feature selection using RF. RF means random forest, and B17 is the highest important features and B23 is the lowest important features. And this is the confusion matrix using random forest. Actually, we have, in order to perform the result, now a question can arise in our mind: how a classifier can measure the performance? How we can measure how we can actually determine the efficiency of a classifier on a proposed data set or on a effective data set. Some important numerical measures are important parameters are precision, recall, accuracy, F1 score, and confusion matrix. Now, since actually precision, proportion of normally traditional ways of evaluating machine learning classifiers use the confusion matrix describing the difference between the ground truth of the data set and the model prediction. Using the confusion matrix, one can compute a variety of metrics in order to compare the classifier's performance. Precision means proportion of well-classified examples among examples of the positive class. TP is the ratio of TP to the summation of TP and FP. TP means true positive, FP means false positive. Okay. Now, if we can, this is the actual value, that means the true condition. This is the predicted value, that means it is the predicted condition. Recall, what is recall? Recall can also call true positive rate, proportion of examples of the positive class well classified among all the positive examples. Recall is the ratio of true positive to the summation of true positive and false negative. precision and recall have opposite behavior. Forcing a good precision is detrimental for the recall and vice versa. F1 score is the harmonic mean between precision and recall, and therefore gives equal importance to precision recall. When actually uh, this is the performance of AdaBoost classifier and confusion matrix using AdaBoost classifier. B12 and B14 using same considers the highest features, highest most important features using AdaBoost, and B27 is the lowest important features. Now, actually, confusion matrix based metrics are a good starting point for evaluating classifiers performance. However, these metrics are point estimators, and some users may want to have a fine-grained knowledge of how the classifiers are performing over all the domains of the testing set. Parametric evaluation of classifier performance allows for that more fine-grained look at the classifier behaviors. This is the performance of cat boost classifier. B26 is the highest most important features, and B11 is the lowest important features. Now it is a comparative analysis of the theory post classifiers are from this table. From this table, you can easily see that for the true positive rate is 99.93 is achieved by RF, and lowest true positive rate is achieved 99.94 is achieved by Adams classifier, while the lowest true negative rate is achieved by Adams classifier is 88.312%, and the highest true negative rate is achieved by classifier is capital boosting is 92.405%. This is the performance evaluation of some other precision recall. NPV, NPV means NPV, FDR, FR, FNR accuracy. FDR means false detection rate. FR means false omission rate. FNR means false negative rate. And the highest accuracy is achieved by 99.92% is achieved by RF and catalog boost, cat boost classifier. Comparisons. Now actually, competitive studies reported in 20 that where in reference 20 where NIPBAS provides higher accuracy compared to other algorithms including logistic regression and KNN classifier. The accuracy of NIPBAS reported in the research paper established in 20 is 97.92%, which is lower than the 99.92% accuracy obtained in our work. Another study considers majority voting and AdaBoost algorithms for the highest accuracy close to the accuracy values of our study. However, the research paper 20 uses a different data set and hence cannot be directly compared with the results of our work. So the conclusion is this paper covers the implementation of different machine learning classifiers to predict fraud detection of credit cards. Firstly, the data sets are investigated to check for imbalanced data. Then 3 types of classifiers are implemented for this purpose. The Holder method is used for separating the testing and training samples, 10% testing and 90% training data from the data set. In this case, 90% of the data samples are contracted for training, while the remaining are used for testing. Results show that RF and cat boost achieve an accuracy value of 99.92%, while AdaBoost exhibit an accuracy value of 99.91% in detecting credit card frauds. It can be noted that one challenges of credit card for detection is the lack of many real data sets, as financial institutions do not disclose their transactions. However, the effectiveness of the algorithms will vary with the change in the data set. Hence, the classification and the feature importance algorithms have to be employed to a number of different real data sets to find the best algorithms. Thank you all. This is the references for paper. Thank you all.